Hi, today we'd be talking about format string vulnerability. There are multiple functions which accept format string like printf, snprintf, sprintf, but we'd just be focusing on printf. So, brief introduction to how printf works is if we provide printf some arguments, then it treats the first argument as the format string, which it uses to get the other arguments on the stack. So if we provide multiple arguments to printf, it would store the arguments like this on the stack. So let's say we have a stack and this is a higher stack address, this is the lower stack address, and we know that the stack grows from a higher to lower stack address. So it's going to store the last argument, then the first argument, and then the format string, and then the return address of the function that called the printf. So let us look at some example. The first example, it says the format string is %x, %x, %x followed by 1 comma 2 comma 3. So the first argument here would be 1, the second argument would be 2, the third argument would be 3, and the format string is of course %x, %x, %x. So what it's going to do is it's going to print the first three arguments of the stack. So it's going to print 1, 2, 3 to standard output. Now printf also allows us to control the which argument we want to print from the stack by specifying the offset, and the way we specify the offset is using $$. So if I write $2 $x, that means I want to print the second argument from the stack. So this is going to print 2 because this is the second argument. Argument is the second offset from the format string. So in this way, if I just give $100 $x as the format string to printf, and as we can see that there are no further arguments, then it would just print whatever value is there on the stack at an offset of 100 from the format string. So if we have a bunch of values on the stack, then it would just print the 100th value, the value at the 100th offset. So see, it has the capability to leak any address on the stack, and what is more powerful is that it also has the capability to overwrite any value that is pointed to by the addresses on the stack. Let's look into that. So for the first example, %n comma address, so the first, in this case the first argument that we have is the address. So let's say the binary is a 32-bit binary and the platform is Little Endian. %n, it overwrites the number of bytes that it has already written in the standard output to address. So in this case, before the %n, it has written just 0 bytes, so it's going to write 0 at the value pointed to by address. So let's say initially the address was something, address has this value, this address 0x8beef. Then now the address would become 0x0 because it's going to write 4 bytes, and it'll be overwriting the 4 bytes with 0. Similarly, there are other ways to overwrite, just to have a short overwrite. So %hn would overwrite the last 2 bytes of the address. So the last 2 bytes, because the platform is Little Endian, so this would make address point to this value, this value, and We also have percentage HHN, which will override the last byte. So percentage HN overrides 2 bytes and percentage HHN would override the last byte of the value in pointed to by address. So now the address would become 0x deadbeef. And similarly, so for this example, now percentage n overrides the number of bytes that it has already emitted to the standard output to the first argument on the stack. So in this case, it has already written A in the standard output, so it's going to overwrite 1 to address. So now address would become 1. Similarly, in this case, it has written 2 A's, so that means 2 bytes to the standard output. So the last 2 bytes of address, let's say if initially address was again 0x deadbeef, it was going to overwrite it with 2. So the last 2 bytes, that means BEEF 2, and this was going to overwrite the last byte of the address deadbeef with 3 because it has written 3 A's in the standard output. Now another example is it also allows us to specify the width precision in the format string. So if I write something like %100x, 1, so it's going to append 99 spaces before 1, and then it's going to write those 100 bytes with 1 at the end to the standard output. So it is going to write some 99 spaces and then 1. So this would be treated as that it has already written 100 bytes to the standard output. So I don't need, when I'm trying to overwrite some value with other values, so that I don't need to give a 100 byte length string. Instead, now I can just specify something like this. So if I want to overwrite the value in address with 100, then I can give %100x. So that means this would be treated as that printf has already written 100 bytes in the standard output. %2$n, that means the %2 means the second argument. So here the second argument is address and the first argument is 0. So it would append 99 spaces to 0. And sorry, and it would override address with 100 because it has already written 100 bytes in the standard output. Let's look at an actual exploit, an example of an exploit. If I have a function like this, so the stack would look something like this. If this is the higher address and this is the lower address, then in the beginning I would, before the stack frame, I would have the return address of this function, then I would have the saved EBP, and this is the current stack frame. After that, I'm allocating 8 bytes. So if it's a 32-bit binary, then these 8 bytes would represent the format string, and then I have a variable, so 4 bytes for the variable. Let's say initially its value is 0, so this would be variable and this value would be, so the value on the stack would be 0x0 and this is the variable. Next I'm going to read 8 bytes from the standard input. 0 represents the standard input, and I'm going to read those 8 bytes in format string, and then I'm going to just printf format string. So my format string would be here, let's say, and okay, and then this is the return address of this function for the printf. Okay, so if I give something like %p in the format string, if I give these 8 bytes, then it's going to print out the first 4 arguments on the stack. So it's going to print out the saved EBP. So we see this way we can print out any value from the stack. So if I give something like %5 $P, then it's going to print out the argument at the 5th offset, which is return address from the stack. So I get to know the return address of the stack, and also I can override this return address if I do something like %100x $5 then it would just override the return address with 100. So I can use this to manipulate EBP, to manipulate the return address. I can use this to leak libc address and other important things that are there on the stack. I can examine the stack, and I can manufacture and exploit in order to change the behavior of the binary.